It's day 19. It's Thursday. It's February 13th. And today we're doing a big review of Unit 2. We've been working on Unit 2 for a while now. The plan is that we spend today reviewing everything. Monday, I would like to give out the practice quiz and do more if needed. Tuesday, we will take our quiz. Okay, so that's just a little look at what's ahead. But today on our do now, first part of our problems here is we are finding slope from coordinates. So how do we find slope using coordinates? What do we need?
X2, X1, and Y2, and Y1.
Right. We are using that slope formula where we have an x1, y1, x2, y2. So before I go and label my x's and y's, I'm going to just write out that slope formula again up to the side. And equals y2 minus y1 over x2 minus x1. So this is what we're using. Now let's label our coordinates. x1, x2, and y1, y2. Okay. So I have my coordinates labeled. I have my formula off to the side. What should I do first?
Right, n equals.
Mm-hmm.
We need to identify our y's and our x's and where they go.
Perfect. Okay, so we got to decide where they go. So in my formula, looks like I've got my y's on top. What number am I going to be writing first?
6.
6. That's my y2. And then a minus
5.
5. Good. 6 minus 5. And I'll draw my line. And what numbers am I writing for my x's?
3.
x2 is 3 minus
-2.
-2. Okay. Do we notice anything about this problem?
It needs to be changed to plus.
Yes, we have on the bottom here 3 minus -2. When we have minus negative, we are going to change that to a plus. This is the same thing as 3 plus 2. Okay. So with that in mind, what should I do now?
Take away.
Take away. What am I taking away?
6, take away 5, and
Perfect.
1.
So 6 take away 5 is 1.
And then 3 plus 2 is 5.
Perfect. 3 plus 2 is 5.
Except I didn't do that.
That's okay. What did you do different?
Well, okay, so I'm always confused about those, and this was just probably weird, and I don't know if anyone else gets it. But mine, I did -2 divided by 3, but I still got a 5, but it's a -5.
Okay, so you did -2 minus 3. Did you also have 5 minus 6? Or did you still write 6 minus 5?
I still put 6, take away 5.
Okay, so you just got the order of the way your x's were written mixed up.
Yeah.
Okay.
I got 5 over 1.
Oh, well, okay, so you put the x's on top.
Yeah, I guess I did.
Uh-oh.
I'm struggling.
I mean, my 1's still up top, it's just the 5.
Okay.
I put -5.
I'm
Right.
struggling to remember where to put the numbers.
Where to put the numbers in the formula?
Yeah.
Okay, so let's try and think of some different ways that could help us
Wait,
remember.
no.
Huh.
What I did was I put my y1 under the -2. I
Oh,
it.
So you just labeled your coordinates backwards, didn't you?
Yeah.
Did you do y1, x1?
Yeah.
Ah, that makes sense. Okay, so I'm gonna put a little sticky note here. When we're looking at slope, it's important to remember that all we're doing here is we're finding our rise over run. We know rise, let's see, rise over run. Our rise is our up or down. Our run pretty much always to the right, unless we count it from a different direction. But we know the y-axis goes up and down. So on top, we're always looking at the y values. On bottom, we're always looking at the x values. What's tricky about this is here we're writing y's first.
Yeah.
But in a coordinate, x comes first.
Yeah, that's what had me confused.
Right. That is something that's very easy to mix up. And I think the only way to truly fix that is to just be very careful, slow down whenever you're doing problems, double check that your numbers are in the right places. And I think that using this formula, we haven't really used many formulas in algebra yet. So I think getting used to plugging 4 different numbers into the right place every time, it's just something that takes time to feel comfortable with. So I just introduced this to you yesterday. You guys are doing pretty good for how new it is, I would say.
Mine is always, I'm always confused about putting x1, xy, x2, xy, and then where to put it.
Okay, so let's keep that in mind and let's look at number 2 then. And let's just very slowly go through each of the steps with the labeling and with plugging in our numbers. So let's see. I'm going to rewrite my formula, but this time I'm not going to write any of my y2, y1, x2, or x1. I'm just going to write, and this is what I like to do whenever I'm solving a problem like this. I'm going to give myself m equals, and then a big empty parentheses on top with a minus, and then a big empty parentheses on bottom with a minus. So if we can start by just giving us at least the empty spaces we need to fill in, it's one less thing to think about, one less thing to think, okay, well, I need minus, and then this is a negative, and then, so we've got an empty template to fill in now. So that's what I would start with, creating your empty template. And then let's maybe just think about not the x1, y1. Let's just think about x's and y's. And let's label our coordinate here. So, which of the numbers listed in these coordinates are my x values?
0 and 20.
Good. 0 and 20. So, one at a time, we're just going to label. I know these are my x's. Let's not worry about the number yet. So, if those are my x's, what are my y's?
0 and -10.
Good. 0 and -10. So, let's think about what we need to do. We can almost think of this as us taking this coordinate, my x and y, and maybe we can plug in one coordinate at a time. Maybe that would feel a little bit less like I'm grabbing one, grabbing one, grabbing one, grabbing one, going all over the place. Maybe I say, okay, I know my x on my first coordinate is 0, my y is 0. What goes on top of slope, x or y?
Y.
Y. So I'm going to take my y from there, and that means I'm going to take my x and put it below. And you guys, tell me if this feels harder to do it one coordinate at a time. Or if you just don't like it this way, you can absolutely do it the way we've been doing it. Just trying to think of different ways to simplify the process. So now let's work with our second coordinate. We've got 20 for x, negative 10 for y. What goes on top?
Negative 10.
Good, negative 10. And that leaves us with only 20 left. Something else that we could do to help us remember what goes where is whenever we create that blank template, the empty parentheses, to fill numbers in, if it helps, you could give yourself a little note on here. I know like my y's need to go up top, my x's go on the bottom. Anytime you can give yourself little hints to help you remember steps. I don't know. I'm always somebody that like I have to label everything. I need to use colors, whatever I can to help my brain stay organized. And again, I think this just gets more comfortable with repetition. Hi, Jesse.
I have a quick question.
Yes.
So, I think I corrected the mistakes, but for number 2, I got my numbers switched around. Is
Me
that going to
too.
make a difference? So I've got negative 10 minus 0,
That's what
And
I
then
got. Me too.
20 minus 0.
So you can put them in either order. I'll show you. I can either do this or I can do negative 10 minus 0.
Okay, it's still going to be the same.
You'll get the same
Okay.
answer. Right.
Alrighty.
And here, let's work out both of them and just make sure.
Okay.
So my top one, I have 0 minus negative 10.
10.
That's going to be 10 because we have that minus minus, that becomes a plus. And then 0 minus 20, negative 20. See. Oh, this wouldn't be negative 20 minus 0. Our x is positive. Okay, so we have negative 20. And we'll simplify that here in a minute. So let's make sure we got everything right here. I've got my y2, negative 10 minus 0, positive 20 for my x2 minus 0, x1. So negative 10 minus 0, what is that?
Negative 10.
Negative 10 over 20 minus 0, what's that?
20.
20. So we're going to get the same answer. I have positive 10 over negative 20 or negative
Okay.
10 over positive 20. Either way, we have one positive, one negative. They end up being the same kind of answer. Now, what would this simplify to?
2.
Okay. I got negative
Almost.
1/2.
2 over 1.
Negative 2.
Not negative 2 over 1. Which number is the bigger one, and is it on the top or the bottom?
Watch my
1/2. Yes. We have 1 over negative 2, or negative 1 over 2. Our slope here is going to be negative 1/2. Okay.
0.5.
4.5, yes, that works too. Okay. Any questions on number 2? You guys get that one?
I
How
got
did you
the
get
numbers too,
negative?
so that's
Yeah.
just good.
How'd I get negative 1 over 2?
Yeah.
So we started with 10 over 20, right? And it's negative. What we do there is we are just simplifying. I know 10 divided by 10 is 1. 20 divided by 10 is 2. And if you ever have a fraction where there's zeros at the end, I can cancel out zeros like this. So that's just a new rule you can think of. If you have zeros. Right. Okay. You guys want to look at number 3? Okay, let's look at 3. What should we do first?
Your X, Y.
Yes, let's label our X's and Y's. I've got X1 for 16, X2, negative 10. y1 for -4, y2 for 3. Okay. Have my x's and y's labeled. What should I do next?
M equals.
Okay, that's right. Equals.
3.
Give myself these. Okay, so 3 is my y2, good.
Minus 2. Or minus 2.
Minus
Where did I get that?
-4. That's okay. I bet you
was
peeked up
looking.
to a different one.
I was referencing my last question.
That's okay. So we have 3 minus -4. And let's look at our x's. What goes on the bottom?
-10.
-10 is x2, good. Minus 16. Okay. What is 3 minus -4?
7.
7. The minus negative turns into pluses. So we have 7. And -10 minus 16.
-26.
Yes, -26. It's just like having a plus a negative. -10 plus -16, -26. Okay, so that should be our answer. Either 7 over -26 or -7 over 26.
Yeah, my answer.
What'd you get, Lisa?
-1, 5, 6.
-1 over 6? Okay, let's see. I bet you did 3 minus 4. Because that would give you a -1. And then -10 and 16. I can see where you got your answer. Okay.
I forgot to turn my negative into positive. I had a -7 over 0.6, but I always forget to change them. Yeah,
That's okay. That's okay.
I
I think,
had the numbers right. I just didn't have
Right.
Put the minus sign.
and I will
negative
say
sign
that's
in the
why
wrong
it's
spot.
always a good idea to double check your answers with your calculator. Because if you type it in right, it'll always give you the right answer. Okay. Any questions on numbers 1 to 3? Okay. This is a topic that we will cover today more because I think it would be helpful for us. But let's go ahead and transition down to numbers 4 through 6. This is a little review from earlier in this week and last week.
That's right.
We've got some different linear equations, and I wanted you to identify the slope and the y-intercept for each of them. So, number 1, what form is this equation in?
Standard.
Standard form, right. This is a standard form equation, which means we're using A, B, and C to find our slope and y-intercept. Now, do you guys remember what the slope formula is? Not the one we used above, but the one for whenever we're finding slope from a standard form equation.
-A.
-A over B. Good. What about y-intercept?
C over B.
C over B. Good. Okay. So, what do I do first?
Write it out. So 2 is A, 4 is B, and 6 is C.
Good. A is 2, B is 4, C is 16. What should I do from there?
Stack them.
Stack them.
So 2 over 4.
Ah, yes. So, A is 2, which means -A is -2. And B is 4, stays the same. -2 over 4. Can we simplify?
Yeah.
We can. What does that simplify to?
1/2.
1/2. Now is it
Negative.
Yes, -1/2. Good. -1/2. That is our slope. What's our y-intercept?
16/4.
Good, 16/4. What does that simplify to? 4. It's just 4. 16 divided by 4 is 4. Good. Okay, any questions on number 4? Okay. Let's go ahead and look at number 5 then. What form is this equation in?
Y-intercept.
Yes. So slope intercept.
intercept,
That's okay.
yeah.
That's okay. It's so easy to mix that up. This is a slope intercept equation. It's in slope intercept form. So what variable would be the one that I'm looking at for slope? I'm looking at my number next to x, which is -2, and y equals mx plus b. We remember our slope is the m, so in this case, it's -2. You could also write -2/1, both are correct. How about the y-intercept? 3, good. Or b. That's good. My b gives me the y-intercept, so 3. Okay. Those are usually pretty straightforward, but do we have any questions about number 5? Okay. Reach my paper just a little. Let's look at our last one, number 6. What should we do first? Yes, let's label our A, B, and C. What's my A?
-3.
Good. -3. What's B? -2. What's C? 6. Okay. So my slope is -a/b. So if A is -3, what's -a?
Positive.
Positive. Good. So that would make +3/b, which is -2. And that is your slope. Or you could say -3/2. Both the same. And how do I find y-intercept?
6/2.
Yes, my c/b, that's 6/2. -3. Good. Okay. These are all the answers to our do now today. So I'm going to go ahead and move this to the side. Does anybody need to see anything on here still?
I can write it down. Number 2.
Number 2. Okay, good. Me. Didn't want to let people write things. Okay, so moving from the do now, let's go ahead and I'm going to start a page of notes. And on this page, I'm just writing down all of the different things that we've covered in Unit 2. You don't necessarily have to copy this list out with me, but let's just organize our thoughts, make sure that we feel decent about all the different things we've been talking about, and let's figure out what items we would benefit from focusing on most today. So in Unit 2, we have been talking about linear equations inequalities. So this is the main topic of Unit 2. I'm going to label this as page 1. And it is, gosh, it's day 19 today. So we have learned how to graph an equation. We've learned how to do that by using the y-intercept as a starting point and the slope to find the second point. We know how to identify the slope and y-intercept in both slope-intercept form and in standard form. So that is our y equals mx plus b and our ax plus b y equals c. So we know how to do it with both of these, or at least we've talked about doing it with both of these. We have not only graphed equations, we also learned how to graph inequalities, linear inequalities. Inequalities, that's where we either have a solid line or a dotted line. And that's where we shade our graph either above the line or below the line. Let's see. The other thing we talked about, man, we've done a lot this unit. There's also graphing systems of equations. Where we have two different lines that we graph, and our solution is that intersection coordinate. So, oh, and then one last thing, we learned how to find slope from coordinates. Done a lot of things. Done quite a few things here. I am gonna just pull up a graph. Let's just talk about a few of each of these. So let's talk about graphing equations and graphing the systems of equations. That's gonna be these two. And as we went through this unit and I was rating your guys' exit tickets, I noticed that from my perspective, it seems like the graphing, funny enough, you guys seem to be almost the best at that. You guys are really getting good at graphing the lines and finding your points, your intersections. I feel like that's something we're all getting fairly comfortable with. So that really also includes finding the slope and y-intercept. These three all kind of go together. So let's just talk about the different kinds of equations that we will need to be comfortable graphing whenever we do take our quiz next week. So I'm going to push this forward and we're going to look at some graphs. So the first kind of equation that we graph is the y-intercept and slope one. That's our slope-intercept form. Y equals mx plus b. Give you guys a minute to get some paper if you need to. So, just a quick review. When we have an equation in y equals mx plus b, just like in the do now, just like we've been doing, we know we need to identify our slope and our y-intercept first. So if I have, for example, y equals negative 3x plus 2, what is the first thing I should do to help me graph this line?
Find your slope and your y-intercept.
Yes, we're going to find our slope and our y-intercept. So what are those values going to be?
Y-intercept is 2.
Good. My y-intercept is 2.
The slope is negative 3/1.
Perfect. My slope is negative 3/1. Okay. So I see my slope. I see my y-intercept. Where do I go to graph? How do I start this?
2.
Yes, we use our y-intercept first. We start at 2 on the y-axis. And where do we go from there?
Down
Yep.
3,
Down 3. Good. 1, 2, 3
over 1.
over 1. Very, very nice. And what's our last step? Put a line through it. Connect your dots. Okay. So, I would say we know fairly well how to graph an equation in slope-intercept form. You guys have gotten pretty comfortable with that. Now, let's talk about a system of equations. It's the same thing, but let's just add one more equation. So, what if I gave you on the same graph also, let's see, how about y equals 4x minus 4. How would I graph this?
The y-intercept is negative 4.
Good.
The slope is 4/1.
Good. My y-intercept is negative 4. That's where I'll start. And my slope is positive 4. 4/1. So I've put my first point at negative 4, and where do I go next?
Up 4/1.
Up 4/1. 1, 2, 3, 4/1. Now, this is a rare case where I came up with a random equation, and the lines are not crossing at a perfect intersection. We'll see that whenever we connect the dots. Let's do that first. Let's connect the dots. We'll zoom in real close for this. Yes. Now, On your quiz, I'll make sure to give you equations where you don't have to guess what the point is where they intersect. It will land on a nice, clean, even point. But in this case, our intersection is not on a perfect point. It's somewhere in the middle of something. So let's pretend. Well, let's see. Let's see if we can just give an estimation of what this intersection would be. What would our x value be?
1.
About 1. Can we make a guess on the y? It's not quite to -1.
It's positive.
Well, is it above the x-axis? Is it positive?
-0.5.
Yes, it's actually going to be negative because we are below the x-axis. We're down here at the negatives, but we're not all the way to -1. So I would say this is about -0.5. Again, I won't give you one like this, but I guess I just accidentally did. So sorry about that.
That's happened before, but that's when I accidentally got the numbers.
Right,
And
right.
I was like, oh, didn't go over that.
Okay, so we just graphed an equation, we graphed a system of equations, we found an intersection, we labeled a point. On a scale of maybe 1 to 10, hold up like your fingers, tell me how good do you feel about doing this on your own? Okay, I see 10, 9, that's good. Girl, don't lie to me.
No, seriously.
I know you feel
I'm
better.
not, literally, am I kidding?
Okay, well let's go over this some more
I
then.
think it is a joke.
Okay, I thought you were playing with me because
No,
I
I'm
know
gonna
you.
be playing.
I know you know how to do this. I think we just need refreshers.
My problem is it's always, I don't know why, but for me, I get very confused and I get very, like, I have to stop
Right.
and think about doing the one little dash, -0.5, whatever.
Oh, on the coordinate.
Yeah, that just makes me want to be like, what, huh?
Right. Okay, so how about this? Let me give you one that's not
Everything
on a
else,
weird
I'm
spot.
good.
Okay, so
That-
not 0. Let's say that I would say maybe an 8. You think? Because you got this.
We'll take 7.
Okay, we'll take
Not
7.
8.
So here, let me give you another one, and I'm gonna make sure that it actually does cross at a point. So, how about y equals x plus 1. There's our first line. Let me think about this. Equals. Here, let me pause this so it's not wasting time on the video. And we'll do y equals -x plus 5. Okay. So we're going to graph this system of equations and we're going to find our intersection. How do I graph y equals x plus 1?
Start with +1.
Start with +1. That's my y-intercept. So I'm going to go to 1 on the y-axis. Now, where do I go from there?
Up 1/1.
Up 1/1. No number next to x means our slope is 1. So, we go up 1/1. Keep going with it if we want. Okay, and let's connect our dots. And then how do we graph the second line?
5.
5 is going to be our starting point. Y-axis. Where do we go from there?
Down one.
Down 1 over 1.
Good. With -1 as our slope this time. So we go down 1 over 1. Down. We'll connect the dots. And this time we have a nice clean intersection. So let's think about it. And we're going to do this part slowly this time. So I see that this is the point where my lines are intersecting. This is where they cross. So my solution needs to be a coordinate. And in a coordinate, what comes first, the x value or the y value? X value. So I'm going to just put a little x right here. So y goes next. Okay. So describe to me, how are we going to figure out what the x value is? How do we do that? So I'm finding the x.
Down.
Okay, yeah. So I'm going down, like drawing a line down, kind of this. And it lines up on the x-axis where? What point?
2.
The 2. So 2 is my x. That's where it lines up on the x-axis. Okay, so now let's see where the point lines up on the y-axis. Here's my point at 3. Good. I'm going to go over and I touch it and I land on 3. So we can fill in our y value as 3. And that would be our solution. Right. And does that help a little bit to see kind of the lines drawn where it lines up with? Okay, good deal. I'll make sure to do that more because personally it helps me too. I like being able to see. I'm very visual, and I know some of us in here are also very visual. So anything we can do visually, we'll do visually. Okay, any questions about the process of graphing systems and finding the intersection? Is there any part of this that any of you are just lost on? Or are we feeling okay about it? That's good. Okay, so let's see. Let's look at a couple of our special cases now. What if I have an equation like this? What if I give you just y equals 3? Now, before we do this, I do want to point out at the front of the room, if you haven't seen it yet, I did make that poster for you guys like I promised I would. That will not be taken down. It's up on the whiteboard by the timer with a little helper guide that you can peek up at. And it should help you with remembering what certain equations might look like, remembering slope, remembering y-intercept, all of those things. Is everybody able to see that from where they are?
Yeah.
Okay, good. Good. So, I wonder if I can Let me pause this again. Okay, so here's that little poster I made. And I guess I'm going to use a ruler and I'm going to point. So we have our slope-intercept form equation here. And this is what we just practiced. We practiced graphing this. We know m is our slope, our y-intercept is b. Okay. Now, standard form, we did a little bit of that in the do now, where we take our a, b, and c. We know our slope is negative a over b, and our y-intercept is c over b. Okay. And then here is what we're about to do now. I'm giving you an equation that is y equals a number. So I color coded this. You'll see my y equals equations go which direction?
That's right.
Left to right. Good. They're always going to be a horizontal line at whatever number the equation tells you. The x equals equations are going to be the exact opposite. Which direction do they go? Up and down. Good. So here's two examples of x equals equations on this poster. Okay. And you're just going to make that line going through whatever number they tell you. And then, of course, our steps to graphing, finding the y-intercept. This is not for these types of equations. This is for these types. Then using the slope and connecting the dots. Okay, so this will stay up. Hopefully it helps a little. I could probably, if it's hard to read from where you are, I could probably make copies of like a smaller version if you want a handout of it. Would anybody find that helpful? Would anyone want that, or is this okay up here? Can we see it?
It's okay, okay. For me.
Okay. Well, just let me know if you decide you need it, and I'm happy to make copies if I can figure out how to do that. And yeah, let's go ahead back to our notes. Pause this again while I adjust the camera. Okay, we're back. So now that we've looked at that little guide, how do I graph y equals 3?
Go up to 3 on the y-axis.
Yes.
And any point from left to right on 3.
Yes. Y is always 3. So I know no matter where my x is, my y is always 3. It's gonna just go straight across through 3. So we're just going to connect the dots, or whenever we're graphing something like y equals or x equals, you can also think of it as we're just marking that point on that axis and we're drawing either a horizontal or a vertical, line right through that number. So there is y equals 3. How about x equals 3?
Go to the X
Mm-hmm.
and then find the 3.
Find 3. There it is. Okay. And how does my line go? Up and down. Yes. Up and down. So that is what we'll do. There we go. There's our y equals 3 and our x equals 3. Not too bad. Okay, you guys feel all right about graphing y equals and x equals equations? Good. And hopefully that little guide will help, because you know what? Your brain goes blank when you take the quiz. It'll be right up there on the board. So, all right. It is 10:20. We've looked at our equations that we're graphing in y-intercept, or I'm saying it now too, in slope-intercept form. We can identify our slope and our y-intercept. We can graph a system of equations. We can graph x equals y equals all the things. When we get back from break, we're going to do a little review on graphing the inequalities. And then we're going to do a little review finding slope with the coordinates. So that is all we are doing the rest of today. I do want to say, if those are two topics that you already feel really confident about, we don't have an exit ticket today. It's Thursday. If you decide you're good with what we did so far, I'm not gonna hold you to staying here, but if you feel even a little unsure, come back. Let's do some practice, and we're gonna get us to where we feel good about taking this quiz next week. So we are at 10:21 now. Let's say we start back up no later than 10:45, absolute latest. Shoot for 10:40 though. 10:45. Okay, take a break. I'll see you guys in a few minutes or so. All right, guys, let's get started. We're back from our break. And we just got done talking about equations, finding slope and y-intercept from equations. We graphed a system of equations. Now let's just quickly go over graphing inequality. So let's remind ourselves. I'm gonna bring our notes up for a second. I know you guys made a cheat sheet a little while back. I want to say it was a week and a half ago or so, where we talked about what all of the different symbols can mean in an equation. For example, right, all of the y equals mx plus b's without an equal sign, and we're going to fill in our inequality symbols. Okay, so let's start with this symbol. What is this symbol called? How do we say this?
Greater than.
Greater than. Y is greater than mx plus b. How about this? Greater than or equal to. Good. So let's start with these two. When we have an equation that is y is greater than or equal to mx plus b, we graph our line like normal. We find our y-intercept and then we use our slope. But there's two other little things we need to keep in mind. First, for y is greater than mx plus b, are we going to have a solid line or a dotted line? Dotted. Good. So I'm going to just draw a little dotted line beside it. So greater than or equal to would then be what kind of line? Solid. Good. Now for both of these, whether it's solid or dotted, where do we shade on these lines? Up. Good. You shade above the line to show that it's greater than, it's bigger than. Okay. And then we've got two more symbols that we use.
Less than equal to.
Thank you. Less than, and then less than or equal to. So for less than, what kind of line do we have? Dotted or solid? Dotted again. Good. So less than or equal to what kind of line? Solid. Now for these symbols, the only difference is where we shade. For both of the less than, where do we shade our line? Down. We shade below the line. So, shade below. Shade above. Now we have one exception for our inequalities. And that exception is whenever we have an equation where we don't have a y. It's like an x equals a number equation. So we will either have x is greater than a number, x is less than a number, x is greater than or equal to, or x is less than or equal to. So I'm just gonna You don't have to write this part, but I'm gonna write a little what this means. So let's remind ourselves, a line that we graph that says x is equal to a number, or the greater than, less than, all of that. First of all, what does that line look like? What direction does an x equals line go? Up and down. Good. So it'll go up and down like that on whatever number they give us. Now, if it is greater than, where would we shade? To the right. That's what the positive numbers go. So for x is greater than, we shade right. And so the only other option we have for less than would be to shade to the left. So that's our only exception to the rules, is when we have an equation or an inequality where there's no y, just an x value. So let's do a little practice with these. I'm just going to pull out the paper I was using a minute ago. But before I do that, I'll wait a moment. I see some of us are still writing. Take your time. All right, so let's look at some graphs. I'm going to go to the bottom of the graph paper I've been using. And let's start with this equation. Somebody read this equation to me. How's it read?
Y is greater than negative x plus 2.
Perfect. Y is greater than negative 5x plus 2. So on your quiz, I will give you a little guide to help remember what steps we take. So this is what you will see on your quiz. There will be a spot to write your y-intercept. There will be a spot to write the slope. There will be a little reminder of solid / dotted that you can circle. And then there will be an option that says shade with an up arrow / a down arrow. So you will have a little guide to help you. So with this guide in mind, I would like for one of you, any of you, I don't mind who, guide me through graphing this inequality. Who feels confident to do that? Okay, Amanda, let's hear it. What are you going to do first?
Okay, so first we're gonna plot our y-intercept,
Perfect.
which is 2.
2. Good. My y-intercept is 2.
Yeah, and then you're gonna put a dot on the 2.
Perfect.
And your slope is gonna be negative 5/1.
Negative 5/1.
So you're gonna drop or go down 5 and then over 1.
Okay, so 1, 2, 3, 4, 5/1. So here's my next point.
And then it's gonna be a dotted line.
Good. Dotted line. Go ahead and connect our dots with a dotted line.
And you shade down.
Let's see. What's this symbol again?
Greater than.
So then you're gonna shade
Greater.
that.
Yes, so we have a greater than symbol. And remember, we read from left to right, whichever one the big opening is facing that comes first. That's how we read it. This is greater than because we see the big opening first. Bless you. So we shade up since it's greater. And a good way to do that is to find any point on your line and just go straight up. And I see, okay, I'm on the right side here. I'm going to shade this way. This is above the line. There we go. Now, how about I give you another one? Let's try x negative 3. Before we try this next one, do we have any questions about the inequality we just graphed? Okay, so somebody read this one to me. How would this inequality be read?
X less than negative 3.
Yes, x is less than negative 3. So I'm not going to do this the same way with a y-intercept and a slope. For an x equals inequality, we'll just have the option of solid or dotted. Shading left to right. So somebody guide me through, how am I going to graph this inequality?
Find the -3 on the x.
Good, I'm going to find negative 3 on the x-axis, right there. Mark negative 3. And what should we do from here?
Draw a line up and down.
Draw a line up and down. Okay, now is it a solid or a dotted line?
Dotted.
Dotted line, good. So, dotted line, because it's less than, not less than or equal to, just less than. So we'll draw our dotted line. Okay, and here's where it can be a little tricky since we can't shade above or below. This is where we decide, do we shade left or right?
So left.
To the left, good. Less than, we shade to the left. Here we go. Awesome. How do we feel about the inequalities? You guys feeling okay? Feel like we're able to do these pretty well. I mean, you guys have really done good with this. How about just for fun, we do a y equals? Amanda, is there a certain part that's got you mixed up?
I just don't really know my left from my right because I totally shaded in the.
Oh, no.
That's
So
okay.
here's
I get
a trick that I know helps me a lot, especially for the left to right. Looking at my symbol.
Whatever way it's pointing.
Yes, it's like an arrow. It says to point this way, we shade this
I just
way.
wasn't paying attention.
That's all right. That's all right. Okay, let's do one more inequality, just for good measure. How about this? Who can read this one to me?
Y
Mm-hmm.
greater than or equal to negative 3.
Perfect. Y is greater than or equal to -3. So, how do we graph this inequality?
We're gonna go to the Y, go down to the -3.
Good. We're going to go to the y-axis and go down to -3.
Then, gonna be a solid line going all the way across.
Yes, a solid line going all the way across, left to right.
Yeah.
Then we're going to shade up. Good. It's greater than. We shade up. Awesome. Perfect. Perfect, perfect, perfect. Okay. So that's going to be all the types of inequalities we might see on our quiz. And with any of these topics that we talk about today, the ones that we all got written down, if any of you want any practice problems to take with you, just let me know. And I'm happy to make worksheets. I'm happy to get copies of things for everybody. I love getting feedback from you guys. When you tell me what you need, it helps me help you. Okay, so that takes us here. We've done this now. We've looked at our linear inequalities. Now all that's left is finding slope from two coordinates. And we're going to start by doing it without the formula. Let's start on a graph because there are two different ways that we find slope using coordinates. We can look at it visually and count the rise and run, or we can use the formula. So back to my graph paper. I'm going to give you a line and I want you to find the slope. So if you're writing or drawing this line, I'm going to give you coordinates so that you're able to copy it. I'm going to start with 1 point at my x is -4 and my y is +2. I will label that. Let me pause this. All right, so we have a point at -4, 2. I need to label my x. And let's give another point at way over here. This is going to be at x is 5. Y is -2. Okay, so here's my line. I want us to find the slope. While you're finishing copying this line down, let's think about the process that we're going to use to find the slope. Since we do have coordinates, we always have the option to use the slope formula, but let's also remind ourselves of the way that we can do it visually. It's a little quicker to do it by drawing our rise and run. So with this line, we've got 2 points. We've got one more to the left, one that's more to the right. Which point are we going to start with?
Left.
The left. We're going to go left to right, just like how we read. So if I'm starting with my first point at -4, 2, where do I go to start?
Go for.
I'm going to go down until I'm at the same height as my second point. So I'm going down 4. Let's see. It's 1, 2, 3, 4. Okay. So since I went down 4, what does that tell us?
4 over blank.
Okay, we went down 4. So the first number on top is 4. Now, since we went down 4, do I need to do anything different with this 4?
Negative.
Negative 4. Good. We have a negative 4 for our rise. And where do I go from here to get my next number, my run?
Over to 5.
Over to 5 on the x-axis. And we'll count how far we went. So I draw my line and then I'm going to count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my rise is -4, my run is 9, my slope is -4 over 9. That would be my slope. Okay. Now, finding slope this way, how do you guys feel about this process? Do we feel we need more practice on it, or do you feel confident to do this on your own?
Can you do one more?
We can do one more, absolutely. Now, here's another question. Let's say we don't like keeping track of when I go down, it's negative, when I go up, it's positive, all this and that. Let's say that you prefer to just write 4 over 9 and then decide if it's positive or negative. How could I decide if my line has a positive or a negative slope based off of just how it looks? Is there a way to do that? How do you do that, Holly?
You look at your left dot first, and
Mhm.
then depending on where the right dot is, it depends if it's negative or positive.
Okay, so what would tell me if it was positive or negative?
It's gonna be negative if it's gonna be lower than the other. If it's
Yeah.
higher than the other, then it's gonna be positive.
Yes. So if my left point, the point I start with, if it is higher than my second point, meaning if I go from a high point down to a lower point, I have a negative slope. My line is decreasing. It's going down. It's negative. If my first point is lower and my second point is higher, like this, for example, let's give one here. We'll give you a point at, my x is -1, my y is -2. Another point right here, x is +1, y is 4. So if I were to see a line like this, where my first point is lower and my second one goes higher, it's like I'm going uphill with my slope. My slope is increasing my x or my y values. So this is a positive slope. Positive slope. So I'm going to give you guys a minute. See if you can find the slope of this line. And I'll pause it and let you guys try this on your own for a moment. And if you think you got it, then I guess you can wait a minute. I'll pause this. All right, so what did you guys get for your slope on this line here?
I got 6 over 2 or 3 over 1.
Okay,
6
6
over 2.
over 2 or 3 over 1. Did anyone get something different besides 6 over 2 or 3 over 1?
That's what I got.
Awesome. Did every single person in this room get this answer? 6
No.
over 2? What'd you get?
I'm not gonna say. Yeah, confused.
So we're right. We're going to start on this point on the left side, the lower point, and we want to find our rise first. We're either going to go up or down to get to our next point. So do we go up or down? Up. Good. My next point's right here at 4, so I'm going to make sure I draw all the way up to the same height of that 4. And let's count how many spaces we went up. So 1, 2, 3, 4, 5, 6. Okay, so I went up 6 spaces. If I go up 6, what does that mean my rise is? 6, good. So my rise is 6. Is it positive or negative? Positive. When we go up, it's positive. Good. So I just went up 6. I found my rise. How can I find my run? I'm going to go over from where I left off there to my point, and I can count 1, 2. So I went over 2 spaces. So what's my run? 2. Okay, so if my rise is 6 and my run is 2, what is my slope?
6, so we got
6 over 2. Or when we simplify, it will turn out to be 3 over 1. Good. Good. Okay. So if you got 3 over 1 or 6 over 2, you are correct. Very nice, guys. Let's look at this one now. This next one. Which point should we start with? The left point, the one right here. So, am I going to count my rise or my run first from here? Let's do the rise, okay? So, am I going up to my next point or down? Down, good. And it's right there. How many did I go?
1.
Down 1. So, if I went down 1, what's the number for my rise?
-1.
-1. Good. And I'm just going to go over for my run, and let's count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 9. Did you guys get 9?
Yep.
Okay, so 9 is my run. What's my slope?
-1 and 9.
Perfect. -1 over 9. Beautiful. Okay, there we go. There's a few examples of doing the slope visually. We have one last thing to review. One last thing. Okay, and that is to do the slope formula. So I am going to have us use the same points that we used on these graphs. That way we have kind of an answer key. We'll be able to check and see if we're getting the right numbers. I'm going to put this to the side and pull out my notes. I'm just going to start a second page here. And I'm going to write down all of those coordinates. So, before I do that, let's write out our slope formula. So we have m equals, show my big parentheses. Now we've got x's and y's. Which goes on top, x or y? Y. So y2 minus y1 over x2 minus x1. And we are going to find the slope using these coordinates. Let's see, we have -4, 2, 5, -2. -1, -2. -4, 1, and 5, 0. Okay. So whenever we are using the slope formula, there's a few steps that we can take. Just gonna write down a little step guide to the side. Optional for you to copy down. You don't have to, but if it helps, you're free to. So using my slope formula, first, I would want to label my coordinates as x1, x2, and y1, y2. What's left to do is plug them in and solve. Plug in values and solve. Y's go on top. And on bottom. So let's go through number 1 together, and then 2 and 3, I'm going to have you try by yourselves. And we'll do number 1 nice and slow. So for number 1, using these coordinates here, what could we do first to start this problem?
Label your X's and your Y's.
Yes, let's label my X's and my Y's. Now in a coordinate, what comes first, X or Y?
X.
Oh.
That's okay. In the formula, the Y comes first. But in the coordinate, X comes first.
Okay.
So we have X then Y, X then Y. So I'm labeling my X's and my Y's, and I'm gonna number them as well. Remember, my 1s need to be together and my 2s need to be together. Got them labeled. I wonder if, I don't know, maybe if it helps any of you, maybe circling them just to really help separate and label them. If that helps, you could do that too. I'm just trying to throw out ideas. You could even list them out to the side if that would be helpful. So once we have our values labeled from our coordinates, what should we do next?
Numbers.
We're going to plug in our numbers. Okay, so I will always suggest and recommend you doing it this way. I like to give myself the formula written out empty with nothing in it. I like to write M equals big parentheses with a minus in the middle over big parentheses with a minus in the middle. This gives you a nice little format to easily plug your numbers into. And now when we're plugging our numbers in, what goes on top of the fraction? X or Y?
Y.
Y. Good. So I'm just going to write a little Y next to it and a little X next to it just to remind myself what I'm going to be putting there. So what should I write on top?
-2
-2
-2.
minus 2. Good. Got -2 minus 2. So since I used my second coordinate first in my problem, then I need to do the same when I go to the x's. I need to make sure that whatever number goes with the second coordinate for x, that I list that first. Need to be consistent with it. So what do I write on the bottom portion of this?
5 minus -4.
Perfect. 5 minus -4. Okay. Once you have your numbers plugged in, we just got to solve it. Solve the top first. -2 minus 2. Is there another way we could think of this problem that might seem easier?
Addition.
Kind of like addition. When you subtract, it's the same thing as adding a negative number. And since I'm starting with a negative number, sometimes it feels nicer to have numbers with the same signs. So what's -2 plus -2?
4.
-4. Okay. So now my bottom problem is 5 minus -4. Is there a different way we could think of this?
5 plus 4,
5 plus 4. Perfect. What's 5 plus 4?
9.
9. So I have -4 over 9, and that's correct. That's what we got using the picture. Awesome. Okay. So there's us running through the first one. Before I send you off to try 2 and 3 on your own, do we have any questions about number 1? Or is there anything that I could clarify for you. Okay, so I am gonna have you guys try numbers 2 and 3 by yourselves. I'll set a little timer. We'll come back and check our answers. Okay, so I'll pause this real quick. All right, what did we get for number 2? Give me some answers. What did you get for 2? 1? Just 1 by itself?
Yeah.
Okay, 1. Any other answers?
4 out of 2.
4 over 2. Anything else?
-4/9.
-4 over 9.
6 over 2.
And 6 over 2. Oh my goodness, we got a lot of different answers, guys. Hey, but this is all for number 2, right?
Oh, no, sorry.
Oh, okay. Which one for number 2? What'd you get?
I got 3/1.
Okay, 3 over 1. Okay, so the 2 people that got 6 over 2 and 3 over 1, those are the same. So 2 people got the same thing. Somebody got 1, somebody got 4 over 2. So let's see. I know looking at our paper, we can see which one is correct. This was our slope. It was 3 over 1 or 6 over 2. But let's go through the process together and see how we got those numbers. Let's make sure we understand what we need to do.
I quit.
It's okay.
I'll see you tomorrow.
Guys, yes, if you need help, please come tomorrow. I'm so
I
more than
agree.
happy
I
to
agree with
work with
Barbara.
you. Okay, so
I'm getting upset.
So I'll see you tomorrow.
tell me which my values are for x. Give me my x values.
4 minus 2. Wait a minute.
Oh,
Here, let's start by labeling our coordinates.
Okay,
Let's
your x
label.
values is -1 and 1.
Good. -1, that'll be my x1. +1, that'll be my x2. Let's look at our y values now.
2 is y1 and 4 is y2.
Okay, so I've actually got a -2 for
Oh,
y1.
-2.
Okay,
Okay.
okay. Do you think you had did you copy it down wrong? Did you have +2 written in your first coordinate maybe?
I did, but
Because that would change
Yeah.
your answer.
yeah. I did.
Okay. Well, then your answer might be right if it was +2. I can check that and see. Okay, so let's see. I have my value for x1 and x2, y1 and y2. Now let's write out n equals, and we'll do empty parentheses over empty parentheses. And let's just start slowly. We've got empty parentheses. We've got our values labeled. Do I start by writing in x values on top or y values on top? Y values. Oops, I called that y1. My bad. Okay. So if my top numbers need to be y2 minus y1, what am I writing on top?
4.
4 minus what? -2. Okay, so I plugged in my y2, that's 4, minus my y1, that's -2. So now I have 4 minus -2.
That's where I got my 2 from. I just didn't plug in the minus.
I gotcha. So did you end up with 4 minus 2?
Yeah.
And then you got 2, and then you did 1 minus -1, 1 plus 1, 2, 2 over 2. Okay, so if this was a +2, you did it right. You did do it perfectly correct, Amanda. This would be the correct slope if we had a 2. So you still got it right. Now let's use the values we see here, though. We've got 4 minus -2 for our y's. Let's move to the x's. We're going to do x2 minus x1. So what's my x2 value?
1.
1 minus, what's x1?
Negative.
-1. Good. So I have 4 minus -2. 1 minus negative 1. Okay. Now, as we're working through this, if you didn't get 6 over 2 or 3 over 1, make sure you're checking your work and seeing what step did I mess up on? What did I miss?
I got the 6 over 2. It's
Okay.
just, you wasn't supposed to have no negatives by it, right?
No
Yes,
negatives.
and that's what I.
So what answer did you get?
I got 6 over 2, but I put,
Negative 6 over 2?
yeah.
Okay, I gotcha. So do you think the negative came just from the fact that we've got like negative numbers we're messing with in here?
No.
I wonder where your negative came
All this damn calculator.
from. Maybe something got typed in wrong. That's okay. Okay, so let's start with 4
I
minus
think I put
negative
it there
2.
because I seen the negative 2. I
Right,
don't know. It
right.
just throws me off.
That's
Yeah.
okay. So we have 4 minus negative 2. What happens when I have minus negative?
They changed the positive.
Changes to a plus. This is a positive. Yes, we
That's
can
where
do.
my mind just can't get it.
That's all right. That's all right. We got so much time on Friday too to come and practice, and we have Monday. We're gonna do the practice quiz. I have 3 whole hours with you guys. The practice quiz will probably take an hour. Then that's 2 whole hours that if you feel good, you can go. You can come and you can stay for those 2 hours with me, and we can go over as much as you feel like you need. Okay. So I don't want anybody to feel like they're just lost and there's no hope for them. I'm here to help. I promise you, we will get you to where you feel so good about this. You will. So we have 4 plus 2 now, and that is 6. 1 minus negative 1, what's that turn into? 2. 1 plus 1, 2. So our answer is 6 over 2, which simplifies to 3 over 1.
I still have a question.
Yes.
How do we know when we need to simplify an answer?
Good question. How do we know when we need to simplify an answer? So here's what I kind of do in my head when I'm mentally deciding, do I need to simplify? For example, on number 1, we can't simplify. The way that we would know if we can simplify or not is by seeing if there's any numbers that I can divide my top number by and my bottom number by. That's bigger than 1. So I can divide these both by 1, but that won't change my answer. Then I would start, can I divide by 2? Well, I can divide negative 4 by 2, but 9 divided by 2 gives me a decimal.
So basically, if they're like on the multiplication table, if it gives us, because
Yes.
6 times 2 is 30.
Yes.
Divided by 2 is 30.
Right.
So it's just if we can make the numbers smaller without going into a decimal range.
Yes, exactly. We're reducing the fraction. Maybe that's a better way to say it, reduce rather than simplify. We're reducing it.
Because 6 over 2 is correct,
Mhm.
unless it is asking us to simplify it. Right?
Yes. That's perfect. No, that's a great way to think of it. Awesome. Okay.
I also accidentally wrote negative 4. Because I instead of putting the comma, I accidentally put minus, so I was like, oh, negative 4.
Gotcha.
So
I
at
see.
first, I got negative 2 over 2.
Okay. That makes total sense. Because that is probably what you get, isn't it? Negative 4.
I caught it though before we started.
Right. Well, good catch. You got it. Okay. Can we do number 3?
Yes.
Okay. Let's do it. What should I do first?
Do the Y and the X.
Label my Y's and my X's? Okay, so Lisa, tell me, what am I labeling each of these?
0 to, or 0 by 2,
Okay, so 0, this is my Y. 2,
and then 1, y, 1.
good. Got my Y's. Okay, then what?
X, 5. And then it's a little 2,
2, perfect.
and then the X, 1.
Perfect. And x1 is -4. Beautiful, beautiful. Okay. Now what?
Now you're going to do the n equals 0, -1.
Okay, so you are writing m equals 0 minus
away
1.
one.
Perfect. Okay. So we have our y2 is 0. My y1 is 1. So I have 0 minus 1 on top.
And then you're gonna do 5,
Mm-hmm.
take away -3.
Perfect.
Maybe plus.
Yes. 5, take away, subtract, -4, which, as Lisa so beautifully recognized, turns into 5 plus 4. Okay, so what's 0 minus 1?
-1.
-1. What's 5 plus 4?
No.
9. -1 over 9. That's our slope. It is correct. Okay. It is 11:50. I'm going to let you guys leave. We did lots of things today, guys. I feel like I've just run us into the ground. It's Thursday. It's the end of the week. We will do our practice quiz on Monday. There will be tons and tons more time for us to review together. If you need any more review, please also know tomorrow, Friday, there is no class. But if you want more help, if you want to run through things with me one-on-one, our office hours are from 9 a.m. until noon, 12 p.m. If you send me a message or an email ahead of time and schedule a time with me, I will reserve that for you. And I will tell other students they have an appointment with me. We are one-on-one for this amount of time. If not, everything else, I've actually never scheduled an appointment with a student. I normally just have people, whoever shows up, and I'll work with you from there. But if you know you need lots of help, set up an appointment with me and I can reserve that time for you. Okay, so just want everybody to know that that is available. And
At 10 o'clock.
that's all